All right, so this lesson will cover how to solve absolute value inequalities. Okay, so there's a difference here. Now we're talking about absolute value. So for example, I'm going to, are you guys okay with the symbols for absolute, for inequality? You guys understand less than or equal to? You understand all of that? Okay, good. So I can save some time by going over that. So what I'm going to do is I'm going to point out some things here. Okay, so less than or less than or equal to problems, solutions, will look like this. Okay, and what I mean like this, when I say like this, I mean this is, you're gonna have -3, okay, -3 less than x, which is less than 3. So it's any problem similar to this one, so it has less than or equal to or less than, it's going to be an inequality just like this one. So I'm going to go back and I'm going to just highlight this part. Okay, and then just to make it as an important note, I'm going to do that. All right, for the next one, notice the difference. This is greater than, so for this one will look something like this. So if you see greater than or equal to, these problems, when you state the solutions, okay, those are going to look, yeah, I misspelled this and I'll correct it. All right, and I'm going to again highlight greater than or equal to. Okay, just to let you know that this is very important. So once you understand this, solving the problems will get easier, and also graphing them. Okay, once you find the solution. So for this one, you have x. Notice that this is greater than, less than -3, or x greater than +3. Now the difference between the graph of these two is the following. So I'm going to plot an open circle at -3. So this is -3. That's an open circle. Okay, and this one is +3. And again, it's an open circle because it's not equal to. So what this is saying is all the values in between -3 and +3 will give you a true statement here. Because, you can always check. If you try to use -4, the absolute value of -4 is 4. And 4 is not less than 3. So if you try to use any values to the left of -3, including -3, this will give you a false statement. Okay? But if you try to use -2, the absolute value of -2 is 2, and 2 is less than 3. So any number between these two open circles that you substitute for inside of the absolute value will give you a true statement. Okay? Now for this one here, however, there's a difference here. Notice that you still go from -3, okay, and from +3. But this is saying from -3, all the values less than -3, so you have to go to the left of -3 so that this will give you true statements. If you go to the right of -3, you will get some false statements because this will be false. So if you do the absolute value of -2, it's +2. 2 is not greater than 3, right? So this is not going to check. And if you try 3, this is also not true. 3 is not greater than 3. So what this is saying is that any value greater than +3 will also be a solution, but the values in between -3 and 3 will give you false statements. Okay? All right. Questions on this? This is the introduction. Okay? So if you get this, then the lesson is really not too difficult. So let's go on to the examples. So this one is asking you to solve each inequality and graph the solution set on a number line. So again, the first thing I see is that the absolute value is isolated, okay, and this is less than or equal to. So then I'm looking at something like this, which means the graph is going to look like this, not like this one, okay? So what I'm going to do next is I'm going to set up an inequality, okay, so watch. So this will be -5 on the left, less than or equal to, I'm going to have this in between, so this will be 2x minus 1, less than or equal to +5. And this is new to both of you. You haven't seen this before. This is not taught in Algebra 1 or Geometry, okay? But this is just like an equation. The goal is to isolate the x, okay? So if it has a -1, the only difference is that you have to do it to the three terms here. So I'm going to add 1 here so I can cancel that 1. I'm going to add it to the 5, and I'm also going to add it to the -5. So then this becomes -4, less than or equal to +2x, which is less than or equal to 5 plus 1 is going to give me a 6. And then you're solving for x. So there's a 2 in front of it. You divide by that 2 on all three terms. Okay? So -4 divided by 2 is -2, less than or equal to, now the x is by itself, and then 6 divided by 2 is 3. So what this is saying is that all the values from -3 to +3 can be used, and they'll give you a true statement in this absolute value inequality. So I'm going to plot a point at -2, and notice that this one is equal to, so I'm going to close the circle. Okay, I'm going to shade it in. 3, and I'm also going to close the circle, and all of these values between -2, +3, including -2 and +3, will give me a true statement for this absolute value inequality. Okay? So, are we okay so far?
Yes.
All right. Let's go on to the next example. Notice this one, greater than. If the absolute value is isolated, meaning you don't have to add, subtract, multiply, divide, you don't have to do anything, then just pay attention to this. So it's going to look like the second one here. So it's going to be disconnected. There's going to be a gap in between the 2 points. So once we know this is isolated, I'm going to break it into 2 inequalities. So one is 2x plus 3, but I'm going to switch the symbol to less than, and that 1 becomes a -1. Okay? So that is 1, and then, or the other inequality is 2x plus 3 greater than +1, and then solve. So subtract 3, and then 2x is less than -4, and then divide by 2. So x is less than -2. So that's going to be the left side of the graph. So this is 1. And then on this one, subtract 3. So 2x is greater than -2. Okay? And then again, divide by 2. So x is greater than -1. So x is less than -2, or x is less than -1. Once we have the solution, we're going to graph this. Okay, so x is less than -2. That happens here. So this is -2, and this is saying less than -2. So that means all of these values to the left of -2 will give us a true statement on the absolute value inequality. And then at x and then x is -1. So from here, it's got to be greater than, so to the right of -1. So all of these values going to positive infinity from -1 will give us a true statement for this inequality. But if you try to use any value between -2 and +1, it's going to give you a false statement. Okay?
Wait, like 2 more seconds. I gotta make that.
So let's go on to the next example. And I wrote over the next example, but I hope you guys can see it on your paper. The absolute value is not isolated. Okay, so there's a -9, so I'm going to add that 9 to isolate the absolute value. So then this is -3 in front of the absolute value of 2x plus 4. Okay, and this is greater than -27 plus 9 is going to be -18. Good. Now I have a -3, so I'm going to divide by that -3 on both sides of the inequality. So then I have the absolute value of 2x plus 4. But watch what happens here. negative divided by negative turns into a positive, so that's going to flip this symbol. Okay, so then this is 6. It's going to be greater than. Okay, you understand? Remember this? If this changes sign, then you got to flip the sign, the symbol. Once we're here, we know when we started with that, this one looks like this. So the graph is going to look like this, and it's going to be an inequality like this one. But no, once we're done, it flipped. So then it's going to look like this graph, okay, when we graph it. So having said that, I'm going to break this into two inequalities. So one is 2x plus 4 less than negative 6, or the other one is 2x plus 4 greater than 6, and then solve. Okay so far?
Okay, why does the last sign switch?
This one here?
Yeah.
Okay, always, whenever you have, if it's greater than, always one of them switches, always. Because this one is the one that is might end up going to the left, right? Remember the graph's going to be split just like this one? Okay, so there's going to be a gap in between. So one goes to the left, the other one goes to the right of the graph. Okay? But they might switch. That's possible. Sometimes they'll switch. So I'm going to subtract this 4. And then I have 2x less than negative 10. And then divide by 2. So x is less than negative 5. There's one side. And then do the same thing with the other one. So for the other one, I'm going to also subtract 4. So then we have 2x greater than 6 minus 4 gives us 2. And last, divide by 2. So x is greater than 1. So x less than negative 5 or x greater than 1. Okay? So once we know the solution set, we can plot the points and graph. So at negative 5, this is not equal to, okay, it's not equal to, so this will be an open circle. So from negative 5, this is going to the left because it's less than negative 5. So all of these values to the left of negative 5 will give us a true statement. Okay? And then at positive 1, all the values greater than positive 1, again, not equal to, so it's an open circle. Any value to the right of positive 1 will give us a true statement on the absolute value inequality. But any value in between negative 5 and positive 1 will give us a false statement because they're not solutions. All right. Any questions?
Why is